In the last movie, you learned about the limitations of converting regular 3ds Max materials into Stingray shaders. But before you move to creating actual Stingray shaders in 3ds Max, so that you don't rely on conversions, let's take a moment to discuss PBR textures. Long gone are the days when a material was simply made out of a diffuse map and a bump map. Today, you want to define a material that is physically accurate in how it deals with reflections, surface roughness, and metallic properties as well. At the very least, as far as Stingray is concerned, you want to account for the following channels: color, normal, metallic, roughness, and ambient occlusion. So you need a set of bitmaps to define a material that is suited for physically based rendering, or PBR. You can view such a set in the files you have downloaded for this tutorial. A download link is available in the movie description. There are many ways to create these textures. You can create them manually, one by one, but this could be a tedious endeavor. You can also use various 3D techniques, such as render to elements, to create some of those, although you would still need to retouch them in a paint program. Usually, you want to use third-party software to do this kind of job, and there are many available products on the market that work rather well. The most common commercial products that regularly receive high praise include Endo 2, Crazy Bump, and Bitmap to Material, B2M. However, if you are not ready to invest in those, you can still create PBR textures using open source software such as Awesome Bump. You can Google it to find and download the latest release. What I like about this app is that it's self-contained and doesn't need to be installed. You simply start it by double-clicking the executable. I admit I'm still using version 4, as I prefer to read tab labels rather than deciphering icons, which is what the latest version displays. Awesome Bump's interface is somewhat unique, but helpful when you get used to it. Aside from the control panel, you have a 3D scene to view your sample result. You can orbit with the left mouse button, zoom in and out with the wheel, and pan with the right mouse button. Holding down the wheel relocates the light source. The 3D settings enable you to change the mesh type, and also switch the environment map. You can also increase the light intensity if you need to. The right window shows you the current 2D image used in the scene, the default being the Awesome Bump logo. The idea is to use this app to create PBR textures from a color image. The general workflow goes like this. First, you need to load a color image, such as this brick texture you downloaded for this tutorial. You can load the image simply by dropping it in the Diffuse panel. If the image is already open in a paint program, you can also use copy and paste functionality. When the image is opened, it shows in 2D in the right pane and also in the left pane as it affects the 3D sample. The color information is there, but the rest of the channels are still influenced by the company logo. What you want to do next is enable preview mode. This lets you make preliminary and global adjustments before fine-tuning them. Once that is done, you want to click on the Convert to Normal Height button to replace the logo by the generated new images. You can exit preview mode after that to see the end results, including the color information. From that point on, you can go into the individual tabs and tune the results for each map. Once you are done, you have the choice of outputting all resulting images at once or individually. I personally like to copy the individual maps to the clipboard and paste them as separate layers in Photoshop for more adjustments if need be. There's another aspect of Awesome Bump that I really like, and that is how it deals with normal directions. Depending on the software you're using, the directions of normals in the resulting image can be inverted. There are endless articles and discussions on the internet about normal flipped axes, so one needs to be wary of that. If you do a search for normal mapping, you'll come across this Wikipedia page that I found quite useful. In it, it suggests that the normal colors for left, right, up, and down, when a normal is protruding, should be as follows. Left is dark cyan, 0, 128, 128. Right is light red, 255, 128, 128. Up is light green, 128, 255, 128. And down is dark magenta, 128, 0, 128. When a normal is embossed, the combination of left-right colors and up-down colors are switched. If only one axis is switched, left-right or up-down, then this could lead to trouble. Armed with this information, let's take a look at a couple of distinct normal conversions. In Photoshop, I'll create a white square over a medium gray background. I'll duplicate this layer so I can see the conversion effect using two different methods. In Photoshop, I will run the free NVIDIA Normal Map filter. You can Google it and download your own free version. It's very easy to use, but certainly not as powerful as other normals tools out there. Once I run it and convert my square image into a normal map, compare it with the standard image we found on Wikipedia. The left and right sides seem to be properly set, but the up and down colors are inverted. If you're not careful, this can give you problems when you use that normal map in a 3D scene, as its interaction with light can be troublesome. Notice the rivets on these two doors and how they are consistent on the right, whereas the light seems to affect them differently on the left. When that happens, you will need to flip the offending axis on the normal channel in order to use it, in this case the vertical or Y channel. If you know of the problem firsthand, you can fix it before generating the normal map. In the case of the NVIDIA filter, you can enable the Invert Y option before you generate the map. If you've already generated the map and cannot undo the work, then here's how you fix the problem. With the Normals layer selected, you need to go to the Channels tab and select the green channel representing the vertical axis. You can now invert that channel using Ctrl-I. If you select the RGB channel again and go back to the Layers tab, your normal map should now show consistent colors. Let's take a look at how Awesome Bump behaves. In Photoshop, pick the grayscale layer and select all its data by pressing Ctrl-A. Next, copy that data to the clipboard using Ctrl-C. Start Awesome Bump and go to the Diffuse tab. Use the Paste button to paste the image. Enable Preview, but set the small, big, and huge weight sliders to 0. Use the medium weight only to achieve a similar look to the one you had a moment ago in Photoshop. Generate a normal map and exit Preview mode. Go to the Normal tab and zoom in on the 2D image. Notice how the colors are consistent with the standard we discussed a moment ago. There is no need for axis conversion here. Mind you, if you did need it, you can flip the axes using the appropriate checkboxes. But the fact that Normal's creation is consistent with established standards makes this tool score higher points in my book. Okay, now that this is out of the way, let's see how we can build PBR shaders in 3ds Max that are 100% compatible with Stingray. This is what you do in the next movie.